Okay, so we're going to start with the algebra skills needed for today. Can everyone say derivative? That's what we're doing today, so hold on. We'll do this offline. I'm going to pick on students like a bully. Here's the first one. All it was asked was FOIL. Just be good FOILers. It's 2 times 2, which is 4. 2h and another 2h if you wrote out the you write them out if you want, but you really got to figure out FOIL fast, I think, at this point. But yeah, I'm just saying. And then h times h is h squared. 4's cancel. Factor out an h, then you cancel. Is that about the same for number 8? Algebra is what we're going to practice today when you're doing a derivative. This is the algebra behind this little thingamajabber. Now watch this. Actually, I'll leave this up to a person in here. Does anyone know what we could do in number 9 in order to simplify the fraction within the fraction? We'll leave that hanging out there for a second. Chapter 8, August. You know, we closed the year with what we started, the algebra that we did, yes? Oh, so close. It's not just 2 plus h. 2 plus h times 2. These are completely different denominators. So what we're going to do is multiply top and bottom by a big gargantuan 2 plus h times 2, because what happens when I throw this up here in the numerator? Who cancels? Who cancels? The 2 plus h's. So you're left with a 2 minus, who cancels when I throw this bad boy or girl into that one? The 2. Now, here's the biggest mistake students make. I've said it all year long. I said it last year if you had me. One of the biggest mistakes is not understanding that it's minus whatever's left over here after you do something. And the thing that's left over is a whole parentheses 2 plus h. I'm going to put that 2 out in front. Do not multiply out the denominator, because you'll see why in a minute. When I distribute, these 2's cancel, and then you're left with negative h over 2h, 2 plus h. Who can cancel? The free h's, the free h there, and the free h outside, not this one. This is part of a binomial. That's the 6 over 5 equals what rule? 2, which is a bad rule. You have a lot of opportunities for that. And then, of course, you could distribute the 2 now, but I just like leaving it like that. So everybody, what are we going to multiply the top and bottom by in this one? This is really getting down to what you're going to have to do today. As a matter of fact, when I show you what we're going to be doing today in our second example of the day, this is what happens. So what am I going to do? I'm going to multiply by a big gargantuan x plus h times x. Why both top and bottom? What is this equal to? 1. This should be in parentheses. This isn't hard, because look at what happens here. What happens? Who cancels? So I know you're looking up and down. When you throw this up here, the x plus h's cancel, and you're just left with an x. This is the point. You get rid of all the little fractions. Minus what happens here. Who cancels? An x. But again, it's x plus h that's being subtracted. So there's how you have to write it. Yeah, just leave that x here. Now when you distribute this minus sign, yes, the x's cancel. And then I should be writing that x first. I'll do it now. Cancel, and this is negative 1 over x times x plus h. I really want to give you, I really hope you understand what I do next here. So let me just pause for a second, let you take a deep breath. Ready for this? Here we go. Draw it. Do it. Do it. Okay, now actually let me zoom in on this picture. And let's just concentrate on that before I show you anything else. Because all it is math notation. So I wanted back in the day to draw a curve of some sort. So I drew a parabola, one that we're comfortable with. And then what I drew was a line that hits this parabola twice. If you remember back in the day, a line that cuts a circle twice was called a secant line, right? How many secant lines can I draw through this red dot? And the answer is an infinite. So does that mean a secant line special? No, not really. Hey, What's the other line when they talk about secant lines in geometry? They always pair it up with what kind of line? Okay, well, it's a kind of line that only crosses a curve once. What's that called? What's a line that only crosses a circle one time? One and only one time. Starts with a T. It's a tangent line. Okay, so I'm going to talk about that in a minute, but let's stick with the secant line and get you to understand what these are. This is easy. Okay, this one coordinate, don't you agree it has an x coordinate, right? X comma, what do you usually put? X comma what? Y. But what's another name for y? What's another name for y? F of x. So this is just the coordinate form using function notation. Ain't no thing. Anyone? Chicken wings. Now, this is a conceptual thing, but it's not a big deal. What I want to do is find this x coordinate. Let's pretend that these two x coordinates are h away from each other. Just deal with it. Don't have a brain gasket blow. All right, so wouldn't you agree then if this is a distance of h, then this x coordinate is x plus h, whatever x is plus that h distance, right? And then what is the comma y? Well, I actually have to call it f of x plus h. That's what the y would be in function notation. Whatever x plus h is, I plug it in and I get y. Right? Now, what's the slope of the secant line? Isn't it this y minus this y over this x minus this x? By the way, let's look at the denominator. What's x plus h minus x? What's x plus h minus x? Just h. So go ahead and throw this little formula down, and then I'm going to get into the calculus. Right? The y minus y over x minus x. So this is the slope of the secant line formula. Now you're probably asking yourself, what's this x and x plus h deal? Why would they do this? Well, I'll get to that in a second after I see people done. Here comes the concept. Hey, what happens if I try to decrease this distance between these two coordinates? So this coordinate gets closer and closer and closer to this coordinate. The closer these two coordinates come together, the more that line starts turning into a blank line. Anyone know what the blank is? Tangent. So as I get closer and closer and closer, dragging this green cord, I should make that green, this gets closer and closer to being the tangent line, right? Theoretically, what if I can make h's distance what number? 0. If I can make that distance 0, then wouldn't it be a tangent line? And wouldn't those two coordinates be right on top of each other? Guess how you do that? Through the glory and power of limits. So as h approaches 0, the green coordinate approaches the red coordinate. And the secant line, therefore, becomes a tangent line. Now, how many tangent lines can I draw through the red coordinate? No. There's only one. That's what makes it special. And actually, it is going to allow us to find a lot of things, both, well, not today. We're just going to use the formula, but tomorrow we'll tell you what it means. Actually, you can do two things at once. And go ahead and write all this down. So, as h gets closer to 0, the green coordinate approaches the red coordinate, and we are almost turning this into a tangent line. So therefore, as h approaches 0, this formula becomes the slope of a tangent line at a given point formula. Now, in calculus, what this pertains to is, this is what I did for my students. I'll talk about that after you write a little bit. I'll talk about that in a minute. Let's get these synonyms down. All right, this is what it's going to look like, and I'm going to have another one of this. Matter of fact, I could go to it. Yeah, so this is kind of redundancies. You're going to see this notation, or you're going to see this notation, which means the instantaneous difference in y compared to the instantaneous difference in x, dy dx. We just told you this is the slope formula for finding tangent lines, which is actually an instantaneous rate of change scenario in a real-world possible equation that I'll talk about in a minute to get you to kind of have a feel for this. And then it's more of the same. This, again, is a redundancy, but I have some other things, like this came from a slope formula. Slope is rise over run. often sometimes said as delta y, right, over delta x, which is the change in y compared to the change in x. Or I will use the term, this is the derivative of f of x. That's what this means when you see this. Or f prime of x. Wow, a mouthful, huh? Okay, now as you're writing all that stuff down, I'll give you that classic formula. What happens when I throw a ball up in the air starting at 100 miles an hour? That's right, 100 miles an hour. What's the initial rate? No, what's the initial rate? 100, but then what happens with the ball right away? Starts what? Slowing down. Okay, so here's how you graph that. Say we start at ground zero, and I throw it at 100 miles an hour, and here's time. Time is just expressed, because it is just going to go straight up and straight down. But I'm mapping it out on an XY axis to get you a feel for what happens, and I'll tell you what the derivative will find. We're actually going to do this tomorrow. The ball is going to go up in 1, 2. What's going to happen? What's the ball doing now? Slowing down. And then what's it actually going to do theoretically? It's going to stop, and then what's going to happen? It's going to speed up and come down, and then hit the ground and splat. Hey, what's the slope of the tangent line right here? 0. You know what the slope of the tangent line also tells you? It tells you the velocity of the object at that point. And what did we just say the velocity of that object was at that point? 0. What's the velocity here, a positive or a negative? Why is it positive? Because the ball is what? Going up. The slope of the tangent line will tell you what that velocity is. What's happening right here? Going down. So what would the velocity be expressed as here? A negative, and it's true. When they say the gravity of Earth is negative 32 feet per second, that's what's happening on us, on our heads, and dragging us down. So we can make an equation out of this, and we can find the first derivative of that equation, and then we can evaluate those velocities. That's what we're going to do tomorrow. It's kind of interesting. But today we're going to do the brass tacks of the algebra. This is 100% Algebra 1, Algebra 2 skills. That's all it is. So we're not doing any velocity because we're just doing the brass tacks of the algebra. Can I do the algebra? Okay, so here we go. We're going to start off with this one. I forgot to do something. Shucks. I forgot to do something. Okay, not in first hour. I did do it in first hour with you guys. Let me just ask you a couple questions. Let's say f of x equals 2x squared minus x. I don't care. What's f of 1? Everyone in the world knows what that answer is. What do we do? What's f of 1? Just plug in 1. Where'd the x go? You're replacing x with 1. What's f of, remember him or her, depending on how do you feel about, what is that? Dead skunks. What's f of dead skunk? 2. Dead skunk got added a little weight, huh? Squared minus dead skunks. They always do that because it's stupid, A. But B, it doesn't matter what I ask you to plug in for X. If that's what I ask you to do, you do it. Remember I told you if I write my own math book, dead skunk's going to be the number one variable. What's f of x plus h then? Oh, this is when everything got crazy. Wherever there's an x, say it. So what? What does this become? 2x plus h squared minus x plus h, and then we'd have to distribute a minus sign. That's it. That's all it means. This is what people jack up when they're doing this stuff. Okay, so here we're going to find the first derivative of f of x. That's what this means. How do we do that? This is the first derivative formula, which is actually just comes from a slope formula that I just derived with that secant line turning into a tangent line. All right? So all you algebraically have to do is limit as h approaches 0. You got to know how to fill in these parts. So after what I just described, what does f of x plus h mean for this question? It means wherever there's an x, I do what? Put an x plus h in for x minus f of x. What's f of x? Well, f of x is just x squared all over h. So what you have to do is accomplish this algebra 1 first. What does it mean to do f of x plus h? It just means plug in an x plus h wherever there's an x in the function that's given to you. And then go from there. Well, now this is why we did the bell work. What does this require? Starts with an f. So what is this foiled out? X squared plus, not just hx, 2hx's plus what? H squared. And then guess what? It's just minus x squared all over h. Oh, by the way, I should stop. How did I say we could evaluate limits? It was the question that you asked me at the beginning of class. What's one way you can evaluate limits? By just plugging in. Can I do that right now? I can't plug in. So it's like the end of the notes Friday when you had to factor and cancel, and then you could substitute. The factor goes away. We were talking about holes. Well, watch what happens algebraically here. Kapow, right? Now what should I do? In the numerator, factor out an h, and then lo and behold, I end up getting that h to cancel. And now what am I allowed to do? Now what am I allowed to do now that those h's canceled? Plug it in. This is that classic hole example I did Friday. That's why I reversed the notes. 2x plus 0. So that's just 2x. So f prime of x equals 2x. And then tomorrow we'll show you how this is used and what we can do with it. The next. Hope I'm saying that right. I know I've seen it as y prime. Hopefully notationally that's right. Talk to your calculus teacher. They'll be more specific. So, find the first derivative of this. I get very angry at non-notational bums, people that don't write everything they're supposed to write because they're lazy. All right, so do write the limit as h approaches 0. The time you don't have to write is when you actually plug it in. That's when it goes away. Can I do that right now? Can I plug in 0 for h? No. Okay, what is f of x plus h? Well, that means wherever there's an x, I put a what in its place? So it's just 1 over x plus h. I think first hour is going around the room making people answer this question. Minus, what's f of x? 1 over x. Oh, that's it. I'm going to get somebody now. So you multiply by, what's wrong? I wasn't before that. I didn't say your name, did I? No, it wasn't going, was it? I think I paused it. It's going now. No, then I hit start. Check the video. I think I'm right. All right. Now, then I'll get a view, and I'll get 1/4 of a penny. All right, here we go. Distribute that. So you multiply both top and bottom by this, because when you distribute that, what happens? You better watch how you say that, sir. X minus the quantity x plus h. That means we have to distribute the minus sign. This is the number one thing that's screwed up on this. Not to go too fast on that. This goes here as well. The x's cancel, and you're left with x plus h. All right, just go ahead and do this. H, x, x plus h on the bottom. You really don't have much more to go. You distribute this minus sign, and then you're left with, let's write one more time. Limit as h approaches 0. Negative h over hx x plus h. Who cancels? These h's on the outside. So now guess what we get to do? Negative 1. Look at what's gone. Because now what I could do is plug in, plug in 0 for h. So what I like writing is the final thing. Now let's do dy dx equals negative 1 over x squared. So we're going to keep going. It's fun. You're going because you said it was difficult. Let's say f of x equals, let's say 2x squared minus x. Give us a chance for distribution errors. So the limit. Oh, we're finding f prime of x. The limit as h approaches 0 of, what's f of x plus h look like? The student I'm pointing to. So wherever there's an x, you do what? So do it. Be the pen. Tell me what to write. This is online. No, just x. X plus h squared minus. Wherever there's an x, put a. X plus h. All right, we'll leave you alone. Okay, I see crinkled eyes. Oh boy. Did we already forget the formula? Are you not looking at the formula on the... This is what I asked you to do. And that is this. Wherever there's an x, what do? Put an x plus h in its place. Minus, what's next, everybody? F of x. So what does that become? Minus squared minus x all over h. Now, this requires foiling. Just requires a little elbow grease, that's all. What's x plus h squared? We just had it on the previous one. X squared plus, oh boy. And then plus what? H squared. And then notice how I wrote this. Minus x, but it's minus x plus h. So it's minus x minus h. And then the end doesn't end up being too bad. Minus 2x squared plus x. But I'm really not ready yet because I didn't distribute my 2 yet. Now watch what happens. Everything that does not have an h in it, what happens? Everything that doesn't have an h actually cancels. You can mark that down, dudes. Because of the nature of what's happening, nature of this formula, that should happen. So what I'm telling you is an error analysis. If you don't have that happen, you made an error. All right, it's almost there. H approaches 0. What are we going to do now if everything has an h? We're going to do what? Take it out. Get 2x plus 2h. What happens when I take an h away from minus h? When I divide it out, it becomes what? Minus 1. That's imperative that you don't make a mistake on that. Now that these cancel, I am allowed to plug in 0 for h. And I get what f prime of x is. 2x minus 1. I'll zoom back and look at the whole thing, how we started and ended. I made a boo-boo. Somebody caught me. Never was good at math. Hey, how about another one? Yeah, you sound like the brother in A Christmas Story. Anyone know what I'm talking about? When he won't eat his meatloaf? Meatloaf, beatloaf. I don't know, something like that. What did we do? Well, I want to make this super special. So, 3 over 2x minus 1. What? I hate Mr. Samuelis. Let's do f prime of x. And then I have one more after this. Okay, so what's f prime of x? The limit as h approaches 0 of, what is it, everyone, in the formula? F of x plus h minus f of x all over h. Let's do this first one. So, the limit as h approaches 0 of, wherever there's an x, what do I put in its place? So this becomes 3 over, let's just do this. Let's distribute it. Can we distribute it too? Can we handle that? So wouldn't that be 2? Fine. Someone said no. Now you don't want to leave this for purposes of what is the least common denominator when I start comparing these? And don't faint. It's not really a big deal. Minus, what's f of x? 3 over 2x minus 1. You just write it there, and then all over h. Now, we should think of this as distributed, and this is the whole denominator. So it's really 2x plus 2h minus 1. And this is 2x minus 1. So what is the LCD that I want to multiply both the top and bottom by? This times this. So that is what we're going to multiply both top and bottom by. 2x plus 2h minus 1 times 2x minus 1. And don't cry about it. Because you know why? You know what happens in the numerator? A bunch of beautiful what? Canceling. So here comes this. Who cancels? The first or the second factor? The first. So what you're left with is, the only thing that's annoying is you have to write this. There's a lot to write. 2x minus 1. Careful! Minus, oh, sorry, times 3, right? Not bad, dogs. All right, and then minus 3 times, who cancels here when I throw this bad boy or girl there? 2x minus 1, so you're left with 2x plus 2h minus 1 all over h. Oh, don't forget about writing this. Remember, you had to multiply top and bottom because this is a form of 1. This is 1. This is just the math you would do in order to simplify this fraction within a fraction. Okay, a little bit of annoyance. I have to distribute 6x minus 3 and then distribute a minus sign, minus 6x minus 6h plus 3. Everything without an h does what? Cancels. A lot of writing. Yes, yes, yes. Cancel, 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 cancel. And then guess what? This is what I'm going to do. You see what I did there? Do you see what I did? Because there is only one thing with an h left. So now what I'm going to do is write it without the limit because I'm going to evaluate. Negative 6 over 2x plus 2 times 0 now minus 1. 2x minus 1. Hey, how many 2x minus 1s do you have on the bottom? How many 2x minus 1s do you have on the bottom? 2. So the derivative is negative 6 over 2x minus 1 squared. Got it? I did give a square root 1, and this is why I did this first hour. Again, what are you finding? The first derivative. So the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's what I have to do for this. Limit. This is very strange. This is why I'm doing the roots one, and you better pay attention. It's strange, but it's not hard. What's f of x plus h? Means wherever there's an x, I have to do what? Put an x. So it just looks like this. A root x plus h plus 1. Not a big deal. I could put it in parentheses, but I don't really need to, and sometimes that confuses. Like they think there's different things going on. Minus, what's next? F of x. So what do I put? Square root of x plus 1. And then all the way back to the whole beginning. How come I can't evaluate this limit right now? Because there's a h in the denominator all by itself, and you can't plug in 0 for a denominator. This is weird, but just do it. And this is obviously only for roots. Whenever you are finding the first derivative of a root, you do the opposite of what you used to do. Rationalize the numerator. So what does that mean I'm going to multiply by? Root x plus h plus 1 plus root x plus 1. Don't faint. All it is Braveheart. What's that mean? What's that mean? When I say Braveheart, that means what? Oh my gosh, I have to reteach this whole year if you guys don't know that answer. Freedom! Heh. Because what's this here? Oh, I don't know if this lasso is going to work. I just feel like I'm smushed too much on this question. Oh, I dragged an extra. No, it didn't work. What is it? Back. I'm glad this is on YouTube. All right. I have to distribute this. What's this times this? What's this times this? Freedom. It's just that free. There isn't any math you had to do there. It's just x plus h plus 1. Why don't I do this and this? Because those two, no matter what, will what? They'll cancel. These are conjugates. If you don't know what a conjugate does and why we do what we do, we got a problem. So what is this? What's root x, let's go over here, plus 1 times a negative root x plus 1. It's a negative freedom. That's all it is, right? Don't forget it's h times those things that I multiplied on the top as well. Unfortunately, that does get stuck down here. But it's not really unfortunate. Because now let's look at the numerator. What happens? What happens in the numerator? Everything that doesn't have an h, what? You distribute this minus, this goes away, and then I could do this. The reason I'm going to do that, and really show that those cancel at the end after everything else goes away. Because now what I'm going to do is plug in. So what's h over h? This turns into 1 over, and then it's x plus 0 plus 1 plus root x plus 1. Hey, how many roots do you see there? 2, and what are those 2 roots? They are exactly the same. So there's 2 root x plus 1s, not just 1. And that's what f prime of x equals. So whenever you're dealing with a radical, the algebra to evaluate the derivative is rationalizing the numerator. It just works because then h ends up being able to be canceled. All right? So we did 5 examples of this. There better be something that sinks in there that we're able to do this algebraically. Now pay attention. Look at what it says there. I only used the book a couple years ago to just pull out the equations that I like to do. Do not even read the directions. Just take the numbers that I've assigned you out of the book and find this for it. How do I do that? The limit formula that I just did 5 times. Do not read the directions. Just find f prime of x.